In this section, we get into some trig functions based on the unit circle, but are not necessarily those quote-unquote nice unit circle points that we have. So we have things like pi over 4s and pi over 3s and pi over 6s, and we know how to find sine and cosine and now tangent by dividing sine and cosine, and we know the three reciprocal trig functions, but what about ones that are not pi over 6s and pi over 3s? How about pi over 27s? What do we do with those? So the first thing is, we sort of remind you what this looks like in terms of the 6 trig functions. If you've got a point on the unit circle, here's your radius of the unit circle, and it doesn't even have to be the unit circle. What if it's the 2-unit circle? What if it's the 3-unit circle? Then r is a different number instead of 1. But that's okay. Cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, tangent is opposite over adjacent. Then you've got your 3 reciprocal trig functions lined up next to each other, so sine and cosecant are reciprocals, cosine and secant are reciprocals, tangent and cotangent are reciprocals. And a reminder, too, that if this is a right triangle, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. Take the square root, and you get the statement that's down the bottom. All right, nothing shocking so far. So the first question here says, the terminal ray of theta contains the point 12, 5. Evaluate the 6 trig functions of theta. So on my coordinate plane, where is 12, 5? It's 12 units to the right, and it's 5 units up. That's theta. So we could use just the numbers 12 and 5, but if we're talking about this as being points on a unit circle, then we want those distances to have a radius of 1. So what do? We figure out what the third side is. If it's 12 units across this way and 5 units across this way, then use the Pythagorean theorem. And actually, this is a special, what they call a Pythagorean triple. 5, 12, 13 is one of those that automatically makes a right triangle. If you didn't remember that or didn't know that, you could do 5 squared plus 12 squared and then take the square root, right? That would give you 25 plus 144 is 169, and then take the square root of that, and you get 13. All right, so from there it asks us to find the 6 trig functions of theta. So here's my point. All right? Remember, the first coordinate is cosine theta. The second one is sine theta. Oh, so it's almost like I've got 4 of them already sitting in front of me. Which 4? Well, cosine theta is 12 over 13. And if I know cosine, I know secant. I know the sine of theta is 5 over 13. If I know sine, then I know cosecant. Now, tan of theta is take sine and divide it by cosine. So take 5 over 13 divided by 12 over 13. But look, if we hit the top and bottom with a 13, right, multiplying by 13 over 13 is the same as multiplying by 1, we get 5 over 12. And if the tangent is 5 over 12, then the cotan is 12 over 5. So those points are also on the unit circle, right? 12 over 13, 5 over 13. They have a radius of 1. All right, these are some special cases. The 6 trig functions for the following angles. So what I'm going to do next to each of these is I'm going to write their ordered pair from the unit circle. So 0 is at the ordered pair 1, 0, right? On the unit circle is right over there. Pi over 2 happens at the top of the unit circle, which is 0, 1. Theta equals pi happens at negative 1, 0, and this happens at the bottom of the unit circle, which is 0, negative 1. All right. And the other thing to remember, too, is that cosine comes first, sine comes second. So here, let's make some columns. For theta equals 0, the cosine of 0 is 1. The sine of 0 is 0. And the tan of 0, well, tangent is sine over cosine, so 0 over 1 is 0. Well, if the cosine is 1, then the secant's also 1. Now we're going to run into trouble with the other two, because 0 is really like 0 over 1, The reciprocal of that is 1 over 0, which is undefined. So it turns out that the cosecant of 0 and the cotangent of 0 are undefined. Okay. How about for pi over 2? So the cosine of pi over 2, write them down to this guy over here. So cosine first, sine second. So cosine of pi over 2 is 0. The sine of pi over 2 is 1. So the tan of pi over 2 is sine over cosine. Well, if I try taking 1 over 0, that's undefined. So for pi over 2, the tangent is undefined. So a couple of lectures ago, we were trying to find the tangent of 90 degrees, and I said the tangent of 90 degrees was undefined. Here's an example of why the tangent of 90 degrees is not defined. All right, so for cosine, flip it over and I get secant. So the secant of pi over 2 is also going to be undefined, because if I try to flip over a 0, I'm going to get 1 over 0, which doesn't exist. Flip over sine, you'll get cosecant. Well, the reciprocal of 1 is just 1. And then cotan is cosine over sine. That's okay. 0 over 1 is 0. All right, and then the other two you can do, right? For pi, essentially, I'm going to get everything for theta equals 0, but with a negative for the ones that exist. And for 3 pi over 2, similar to pi over 2. All right, how about a couple of these? If the tangent is negative and cosine is positive, what are the other 5 trig ratios of theta? So tangent is negative when sine and cosine have opposite signs. So that happens in quadrant 2. It also happens in quadrant 4. All right, how about cosine being positive? Cosine being positive is the right half of the unit circle, right? That's where the x's are positive. So that happens in quadrant 1 and quadrant 4. Well, what do they both share? They both share quadrant 4. So this angle is somewhere in quadrant 4. I'm just going to draw a generic angle down here. It says the tan is negative 1/2. So tangent is opposite over adjacent. So the opposite side is negative 1. The adjacent side is 2. From there, I need to find out what the third side is. So c squared equals a squared plus b squared. Remember, when you square a negative, you got a positive. So 2 squared is 4 plus 1 is 5. So if c squared is 5, then c is the square root of 5. Once I have that, I can find the rest of them, right? The sine of theta, opposite over hypotenuse, so negative 1 over the square root of 5. And then I'm going to rationalize my denominator by hitting top and bottom with the square root of 5. Cosine of theta is adjacent over hypotenuse, so adjacent over hypotenuse. And again, hit top and bottom with the square root of 5 to rationalize my denominator. The tangent was already given to me. From there, I can figure out what the cotan is. Flip that over and I'll get negative 2. And then flip over the 2 that I have, but go back to the first step. In other words, for sine, the reciprocal is cosecant. So just take that 1 over root 5 and make it root 5 over 1. Tack on your negative. For secant, flip over that 2 over root 5, and I'll get root 5 over 2. And there it is. All right, a couple more of these, and then we'll look at reference angles. This gives me the cosine, and it tells me the cosecant is negative. Well, cosecant is the reciprocal of sine. So cosecant being negative means that the sine is also negative. Sine are the y values. So the y values are negative in quadrant 3 and quadrant 4. Here it says the cosine is positive. Cosine is positive in quadrants 1 and 4. So where must this be? Again, this must be in quadrant 4. Cosine is adjacent over hypotenuse. So if I define my angle to be over there, adjacent is 24, hypotenuse is 25. If I use the Pythagorean theorem to find the third side is going to be 7. Again, this is one of those Pythagorean triples, 7, 24, 25. The only thing I'm going to make a note here is that 7 is negative. And so when I go to find my ratios, anytime I need an opposite, the opposite is going to be negative. So the sine of theta, opposite over hypotenuse, so negative 7 over 25. Cosine of theta was given to me. Tan of theta, opposite over adjacent, negative 7 over 24. And then flip the other ones. So the cosecant of theta is the reciprocal of sine. The secant of theta is the reciprocal of cosine. And the cotan of theta is the reciprocal of tan. All right, this one asked me to find cosine and cotan given some information about sine and, in this case, the quadrant where it lives. So, the sine is negative square root of 7 over 4, and I'm between pi and 3 pi over 2, which is another way of saying I'm in the third quadrant. Right? Because there's pi, there's 3 pi over 2. It says the sine is negative square root of 7 over 4. So sine is opposite over hypotenuse. So the hypotenuse is 4. The opposite side is negative square root of 7. I need to find this missing side over here. So something squared plus negative square root of 7 squared equals 4 squared. So a squared plus, if I square a square root, I get back what I started with. Subtract a 7 from both sides. Oh, look, the numbers work out nice. If a squared is 9, then a is 3. And now from here, I think you can finish it, right? Cosine is adjacent over hypotenuse, so 3/4. Cotan, instead of being opposite over adjacent, is adjacent over opposite, so 3 over negative root 7, which when you rationalize it, you'll get negative 3 square root of 7 over 7. Oh my goodness, I turned my negative from being on the bottom to being on the top. Does it matter? No. Right? As long as it's on one of the two, we're okay. All right, the other thing we should look at in this section is something we call reference angles. So the first quadrant angles are called the reference angles for the other angles, and I actually used that word, I think, in the last lecture video without defining it first. So the reference angle is somewhere between 0 and 90 degrees. It takes an angle that's bigger than 90, or perhaps is negative, and turns it back into an angle that's comfortable for us. So look at this first one. Suppose I have, need a different color pen. There we go. So suppose I have an angle that looks like this. This is a big angle, right? Bigger than 90. So the reference angle is the angle that it makes with the x-axis. So you notice that this thing here says theta prime. If you drop a perpendicular down here, this angle over here is the reference angle. It's the acute angle that angle makes between the terminal ray and the x-axis. How about this angle? This is a big angle. It's more than 180. Where's the reference angle here? There's the reference angle. It's the angle that it makes with the x-axis. This one here goes all the way around almost. But again, the reference angle is the acute angle between the, in this case, the positive x-axis and the angle. So state the reference angle for each angle. Where's 250 degrees? 250 degrees is more than 180, but less than 270, right? 270 would be all the way down the bottom of the unit circle. Well, if this is 270, that's 250, that's 180. What's the difference between 250 and 180? It's 70 degrees. That's the reference angle. How about 350? Ooh, that's almost all the way around the unit circle. Or the circle, I should say. 360 would be all the way around. This is 10 degrees shy of 360. So the reference angle for 350 degrees is 10 degrees. 89 degrees is its own reference angle. It's pretty close to the top of that unit of that circle, but not past 90, so it is its own reference angle. Ooh, how about negative 100 degrees? So I start here and I work backwards. There's 90. 90 plus another 10 is 100. So what's left between that and the horizontal? 80 degrees, right? Because this is negative 180. It's also positive 180. So if I go backwards 100, I've got 80 left. How about 526? 526 is all the way around the unit circle once. So take 526 and subtract 360. Now I'm going to go another 166 on top of that. 166 lands me over here with how many degrees between 166 and 180? 14 degrees. All right, so the reference angle is always between 0 and 90. Even if you're going backwards, even if you're going around the circle more than once, still between 0 and 90. All right, last couple of things. Where's trig functions positive? In the first quadrant, everything's positive, right? Because remember that the cosine comes first, sine comes second. So in the first quadrant, x's and y's are both positive, so everything's positive. Over here, the x's are negative, but the y's are positive. So that means that the sine is going to be the positive one. Well, if sine is positive, cosecant's positive also. Down here, they're both negative, right? The x's are negative and the y's are negative. So what's positive down here is tangent. Because remember, tangent is sine over cosine. So take a negative divided by a negative, you get a positive. Well, if tangent is positive, cotan is positive too. And then in the last one, the x's are positive, the y's are negative. So that must mean cosine and secant are positive. Some people have little abbreviations for this. They say it stands for all students take calculus. Some say all students talk constantly. Either one. Whatever makes it easier if you remember it. Or, I don't even remember that anymore. I just think of where the x's are positive and where the y's are positive. Where the x's are positive is where the cosine is. Where the y's are positive is where the sine is positive. Where they're both positive or both negative is where the tangent's positive. All right, this last little bit just asks us to use reference angles to find the value of these trig functions. Let's take a look at a couple of them, maybe not all of them. The sine of 8 pi over 3. Well, 8 pi over 3 is 6 pi over 3 plus 2 pi over 3. 6 pi over 3 is 2 pi. That's once around the circle. So really what this question is asking me for is the sine of 2 pi over 3, and I can go back to a unit circle and look at that. How about the cosecant of 25 pi over 6? What is 25 pi over 6? Well, I recognize 24 pi over 6, right? 24 pi over 6 is 4 pi. So this is around the unit circle twice, right? 2 pi is once around the unit circle, another 2 pi second time around the unit circle. What's left? Just a pi over 6. Okay. How do I find the cosecant of pi over 6? So the cosecant of pi over 6 is the reciprocal of the sine of pi over 6. So if I go back to my unit circle, the sine of pi over 6 is a half. So the cosecant of pi over 6 then must be 2, right? Flip it over. All right, look at the last one. Cosine of negative 9 pi over 4. So what do I know about whole groups of pi's? Well, 4 pi over 4 is pi. So 8 pi over 4 must be 2 pi. All right, does that give me back a negative 9 pi over 4? So sure enough, negative 8 pi over 4 plus negative pi over 4 gives me a negative 9 pi over 4. Well, negative 8 pi over 4 is just negative 2 pi, so this is once around the unit circle going backwards, plus another negative pi over 4. So let's look at the cosine of negative pi over 4. Well, I'll bet you the cosine of negative pi over 4 is the same as the cosine of pi over 4 because they're both positive. So the cosine of pi over 4 is root 2 over 2. So is the cosine of negative pi over 4. All right, so that's how you can use the reference angle. Sometimes you have to go more than once around the circle to get to that angle. Then once you get there, evaluate it as always. And that's the end.